Hey guys, it's Lizzie and Anisha here with a 2-minute tutorial for you. Sound can have a huge influence on the feel and the performance of your space, so it's good to know the basics of acoustic behavior when you're in the prelim stages of building design. This is especially important for the type of project we're currently working on, which is a performing arts center. So, sound and building form influence each other hugely. On the left, we've got some beginner vocab for understanding acoustics, and on the right, we've got some very basic components of building design. In the first half of our video, we're mainly going to be focusing on three main ideas in acoustic design, which are absorption, reverberation, and diffusion. And in the second half, we're going to show you an awesome tool we found called Focus 3, which helps you analyze your building floor plans for acoustical effectiveness. So, like you might have guessed, absorption is a material's ability to absorb or dampen noise. Soft, porous materials are best at doing this because as sound waves hit them, they slow down and their amplitude decreases, which decreases the volume. Intuitively, this makes sense if you've ever seen what sound insulation looks like. Most of it's kind of like giant felt or foam, and other soft things like curtains and carpet can also have a huge sound absorption effect. Reverberation is what happens when sound bounces off of hard surfaces like metal, concrete, or wood. Like in the picture above, spaces with the most reverb are big empty spaces with hard, smooth surfaces, and sound waves just bounce off those and can either direct or create echoes depending on how the space is designed. Lastly, materials with irregular surface textures diffuse sound. And that means that it redirects the sound waves that hit it. So instead of bouncing off at the angle of reflection, you all remember physics 122, right? Those sound waves get kind of spicy and they just go all over the place. So the material's texture reflects sound into multiple directions, and that can be really useful for reducing echo and other noise feedback. I just think this graphic is a really quick, concise way to get those ideas across. The red arrows are sound waves doing what they do in each given scenario, reflecting off of hard surfaces, getting absorbed by soft surfaces, and being diffused by irregular ones. So here in the Philharmonie de Paris, the same acoustic manipulations were achieved using those three material properties. You can see circled on the left that the architect chose material with an irregular surface to diffuse sound hitting that balcony. And in the middle, where the arrows are right above the stage, they used a hard, dense material to reflect the sound into the audience. In this photo, the audience themselves are actually acting as a sound absorber. So the people and equipment in your space matter just as much as the other building material. In our other case studies, you can see how similar design approaches were taken. We don't see many flat, smooth surfaces, whereas we do see lots of convex curves. And you can see this especially in the ceiling at the Disney Concert Hall and in the railings in this case study. Now we can also see that these all use materials to diffuse and absorb sound on any flat, smooth surfaces that do exist. Materials. So with that, I'm going to hand it over to Anisha. She will walk you through Focus 3 and analyzing how the geometry of your building, like the shape of the floor plates, the floor area, and the building height, all influence the acoustics of your space.
The software opens up with this default rectangle, which you can just go ahead and delete. Towards the top corner of the artboard, you can see the different shapes that you can use to recreate your Revit or Rhino model in Plan. At the left corner of the artboard are different tabs that you can use to change the dimensions to reflect what your Revit model says. Over here, I'm recreating the stage area in my Revit model and changing the dimensions to be the same as the ones in my Revit model. You can also change the name of the area by again going to the same area with the tabs and changing the text. I'm now going to recreate my audience and seating area by using one of the same icons at the top corner. You can change the depth, inner radius, and sweep angle of your audience area and to reflect what is on your Revit model. By clicking on Edit and Add Sound Source, you can pick a basic sound source to add to your model. For my project, I chose a basic two-way speaker and placed them in between the stage area and audience area on either side of the project. You can also change the rotation of the sound source at the left corner again. Click on Show Mapping at the top left and you can see the reverberations and decibel levels in your project. On the left, you can see the old plan that we have, and on the right is a new plan. As you can see, we chose to incorporate the information that we gathered from East Focus 3 and have this kind of tapered seating. We chose to do this because the reverberation levels were at an optimum throughout the area.
This is a section of our current building, a performing arts center in Stockton. You can see in this section we've already incorporated some of the curve geometry that is necessary for reflecting sound coming from the stage into the audience. But this dropped ceiling is a problem. It's concave, which means that sound will be a lot louder at its focus point. Since we want to design for an even distribution of sound, changing it to a convex curve is a much better option. And the interior is going to start looking more like this. Other changes we'll make have a lot to do with materiality. We understand now why seating needs to be upholstered, why carpets are desirable, and why acoustic foam panels should be used on at least 2 adjacent surfaces.